Hi everybody, this lesson is going to feature something called the zero product property, which is going to teach you how to solve equations that are a little bit more complex than most of the ones you've been dealing with all of this year. What we're going to take a look at is how do we solve problems that have exponents that are greater than just the power of 1. So all the equations we've been basically dealing with this year have been things like x plus 10 equals 20 or 3x plus 9 equals 37, stuff like that. What we're going to look at here is this property called zero product property, which allows us to actually solve for x when we're dealing with x squareds, maybe even x cubes, and we are going to use all this stuff in relation to all these factoring strategies that you're going to be learning in this chapter. So first I'm going to show you how the zero product property works when everything is already split and factored apart. And then we're going to review how factoring at a GCF works and relate it to this zero product property. So zero product property is basically this. If you have multiple factors, you have things broken apart as far as you can, multiple factors set equal to 0, you can set each of the individual factors equal to 0 to solve for potential x values. Now, this is something you will definitely do a lot, not only in this unit and for the rest of this year, but something for sure in higher level math and algebra 2, pre-calculus, etc., as it connects a lot also to graphing concepts and a whole bunch of other things that you will learn in algebra 2 and moving forward in math. But the long and short of it is, if you have everything factored apart and set equal to 0, you can solve for x. So, a couple things vocabulary wise. Answers have many names, so you might see the word solution, zeros, x-intercepts, roots. All of those different words are basically telling you to do the same thing. Take the factors, set them equal to 0, and go solve. So, let's look here. These four examples have everything pre-factored apart, so I think you'll see after the first one or two how we go about solving these here. So you'll also notice the level of work you might need to show may not be as much as what I'm putting in the notes, but again, I want you to at least have a framework as to where all my answers are coming from. At any rate, let's talk about how we use zero product property to find the roots, the solutions, the answers of these problems. So number one, we have it already factored apart into our two polynomials, x minus 5 times x plus 4 equals 0. We're not going to multiply this together. That's not going to help us at all. When we're trying to solve an equation that has multiple x's in it, we want it factored apart. We want it broken down like you see here on this slide. What we're going to do is take each of those factors and set them equal to 0. So I'm going to take the x minus 5 and set it equal to 0. The x plus 4, set it equal to 0. All I'm going to do for here is solve each of these little equations. So I'd add 5. The first one would be x equals 5. The second one, x equals negative 4. These two values are my solutions for x because I can plug either one of those in. So let's say I plug into 5. 5 minus 5 is 0. 0 times 5 plus 4, which is 9. 0 times 9 is 0. That checks out. If I plug in a negative 4, negative 4 minus 5 is negative 9. Negative 4 plus 4 is 0. Negative 9 times 0 gets me 0. Those two x values work. Those two things will be my solutions. So a lot of what you're going to see in these problems, especially since we're going to start seeing a lot of problems that have squares and cubes, is that you're going to more than likely have more than one answer for x, and that is totally okay. You look at number 2, once again, broken apart into two factors, 5x minus 12, 2x minus 7. Again, when they're broken apart like this, set equal to 0 to solve for x. Again, all we're going to do, take the 5x minus 12, set it equal to 0. Take the 2x minus 7, set it equal to 0. So in the first problem, I'm going to add 12 and then divide by 5. So x would equal 12 fifths. The second one, I'd add 7. So 2x equals 7. Divide by 2. X would equal 7 halves. These are my two answers for x. And you can leave them as fractions, round as decimals. It doesn't really matter. Ultimately, though, those are your answers. Now, the only real difference in 3 and 4 versus 1 and 2. So 1 and 2, my factors, you can clearly see were in sets of parentheses, set them each equal to 0. Just because it's not in parentheses does not mean you ignore it. So you notice number 3, I have a 5x. The reason why there's no parentheses around it is because it's one singular term. I don't technically need parentheses if it's one singular term, like a 5x. If an x plus 2, x minus 5, because of the plus and minus signs, that's why we put parentheses around things. But what I'm going to do is still take each individual factor, so that includes that 5x out front, and set it equal to 0. So again, each of these factors, so 5x is equal to 0, x plus 2 equals 0, x minus 5 equals 0. Again, I'm going to solve for x in each of these. So for the first one, I divide by 5, x would be 0. Second one, I'd subtract by 2, x is negative 2. The last one, I add the 5. I get 3 answers for x, 0, negative 2, and 5. All three of those numbers I can plug in for x and get it to work out and satisfy my equation. So for 4, I would do the exact same thing. I take each factor and set it equal to 0. So I'm going to do that with the negative 8, the 3x minus 6, and the x minus 7. Now, there's one instance here where it's irrelevant if you set it equal to 0, and that's the case here, number 4. So the factor out in front was a negative 8. There is no variable with it, so if I look at it here, I see negative 8 equals 0. That's pretty much irrelevant, because negative 8 can never equal 0. So if there is no variable with your factor, you can technically show me that it's equal to 0, but it's irrelevant to our problem. So if there's an x there, you have to show it because you can solve for x. If there is no variable there, then there's nothing to solve for. So I'm going to go ahead and resume with my other factors because we see variables. So 3x minus 6 equals 0. I'm going to add the 6, divide by 3, means I get x equals 2. And then the last one, I'll add 7, x equals 7. So x is 2 or x is 7, and both values would satisfy that equation. Now, this is by far the easy version of zero product property because it's already been pre-factored for you. What you're going to be doing a lot of in this chapter is using your factoring strategies to break the polynomial part first, and then using this zero product property here to solve for what x could be. So, if we take a look here at this next slide, all 5 of these problems here, we're going to go ahead and review how to factor out a GCF, and then use that in combination with zero product property so that we can solve for x. So, let's take a look here at number 5. We have 3x squared plus 15x equals 0. When it comes to factoring these apart, we don't worry about the equals 0. That part, not super relevant. It will be in terms of having to solve it here in a minute, but what I'm going to worry about factoring is essentially what's out in front. This 3x squared plus 15x. I need to factor that apart first. So again, you only know one strategy, how to factor out a GCF. Let's talk about what you can factor out. So the biggest number you can factor out is a 3. The most in terms of variables is you can take out an x. Your GCF is 3x, and then we show what's left over. So divide 3x away from each of your terms. 3x squared divided by 3x is just x. 15x divided by 3x is 5. So if I'm factoring out a GCF, my factored form of 3x squared plus 15x would be 3x times x plus 5. When you see that equals 0, that is telling you not only do you need to factor, but it also means you need to solve it. So if you see an equal sign, that means you are going to solve the equation and figure out what x could be. So we tack that back on after we factor. We then take each of the factors, set them equal to 0, just like we did on the previous slide. So 3x equals 0, x plus 5 equals 0. Solve for each. So in the first one we divide by 3, x would be 0. Second equation we subtract by 5, x is negative 5. And those are my two answers. X is 0, x is negative 5. If you're not convinced with what you solve for, plug them back into your problem originally and substitute, use your calculator. You can figure out the math pretty quick and make sure that things balance out the way that they should. Number 6, we're going to do the exact same thing. I'm going to focus on factoring apart 22a squared minus 11a first, and then we'll go solve. So the greatest number I can divide out of both of those terms is 11, and variable-wise I can take out an a. What's left over? If I divide 11a out from the first term, I'd be left with 2a. If I take 11a out of the second term, I'd have a negative 1, because the 11a's would cancel, but again, I have to have something there as a placeholder, so that's why I put a 1 there. Close it off, set it equal to 0. Once I factored it, now I set each factor equal to 0. So 11a equals 0. 2a minus 1 equals 0. Solve for each. So the first one, I'd have a equals 0. The second one, I'd add 1, divide by 2. A would equal 1/2, or you could write 0.5, and that would be fine as well. All right, number 7, same idea. So, negative 2x squared plus x. So, let's factor it apart. So, numbers-wise, I see a negative 2 and what would be essentially a positive 1. The only thing I could divide out, so I can't really take anything other than a 1. If it were a positive 1, I wouldn't worry about showing it. But there's a negative leading coefficient. If you recall from the last lesson, one of those little details that you're going to have to keep in mind. If the leading coefficient is negative, you want to make sure that the negative sign comes out with your GCF. So if your GCF is 1, let's pull out a negative with it. And we can also take out an x. So I'm going to take a negative 1x out of each term. I divide that away from everything. I'm left with a positive 2x. If I divide away from the second term, I have a negative 1. And I'm left equal to 0. Same deal. Set each term equal to 0. So I'd have x equals 0. And just like the last problem, I actually end up with the same answers here, ironically enough. I get x equals 1/2. The only difference is the variable changed. Now, this last problem here, number 8. You'll notice there's a key difference between number 8 and what you saw 1 through 7. Look what it's equal to. Right now, it's not equal to 0. It's equal to 24b. Think about zero product property. They don't call it anything else. It's not called the 1 product property. There's not the 5 product property. It's called the 0 product property, which means your equations have to equal 0. So, if I look at number 8, it's not currently equal to 0, but we can manipulate a little bit so that we can make it equal to 0. What we're going to do is we're going to take the term that has the lower variable. So, again, 24b, the b is lower than the b squared to the 9b. I'm going to take that lower term, and I'm going to move it to the other side. What I'm going to do here is I'm going to subtract it. Now, 9b squared minus 24b, those are not like terms. You cannot combine them together by subtraction, so we just write them next to each other. And that equals 0. It has to equal 0 first. If it doesn't equal 0, you need to make it equal 0. So that means you'll need to move terms around left or right to get it to equal 0. That's the only way you're able to solve any of these problems. Once you do this, this now should look like the rest of them, where we're going to focus on factoring apart the left side here, the 9b squared minus 24b, and then we'll solve. So, greatest thing I can take out of these two terms is 3b. What I'll have left over when I divide everything out, I'd have 3b minus 8. Set that equal to 0. Take each of my problems, set them equal to 0, each of my factors I should say. That would leave me with b equals 0 for the first one. The second one, I'd have adding 8, then dividing by 3. I get b equals 8/3. So in general terms, you need to make sure these problems equal 0. A lot of the ones you'll be given will be, but sometimes they aren't. Make sure they equal 0 first. Then you factor apart what you can on the side that has all your terms. Again, all you know so far is GCF. Next lesson, you're going to learn another strategy, and then you'll learn a couple more past that. And then once you have all of your factors broken apart, take each individual factor, set it equal to 0, and solve it like you would a normal equation. So once you practice it a few times, again, this is a pretty, I'd say, easy process once you know how to break these things apart. The biggest trick is making sure you can factor correctly. Once you factor correctly, the solving part is just using your basic algebra skills to get the variable by itself. So last problem here, we have number 9, a little quick word problem here. Let's talk through that. A startled armadillo jumps straight into the air with an initial velocity of 14 feet per second. This movement can be modeled by the equation h equals negative 16t squared plus 14t in which t is the time in seconds the armadillo has been in the air. After how many seconds does it land on the ground? So, you've been given this equation of h equals negative 16t squared plus 14t. Now, the question's asking after how many seconds does it land on the ground? So, we don't know the time. So, t is what we're trying to solve for. Then we have this other variable of h, which is the height. So, think of this logically. Whether you're an armadillo or any other animal or you as a human, if you're trying to figure out how long you can hang in the air while jumping before you hit the ground, ultimately, you're starting from a height of 0 and you end with a height of 0 when you land on the ground. So I'm going to replace this h value with a 0 because ultimately I want to figure out the time it takes to start from ground level, get up in the air, and head back down to ground level. So ultimately my change in height is going to be 0. So once I look at this here, I'm going to connect it right back to what we just did with the other problems up above. Only difference is the 0's on the left, my terms are on the right. We're still going to do this the exact same way we did up above. Let's factor apart the terms that we have. So GCF of those two terms, I can take out numbers-wise a 2 and a t. My leading coefficient is negative, so that's going to come out front with me. If I divide that away from both terms, I'm left with a positive at and a negative 7. This means now I'm going to take each of my factors, so negative 2t equals 0, which means t is 0, and 8t minus 7 equals 0, so t would eventually equal 7/8. So I've got two answers for t. So it's asking the time in seconds the armadillo would have been in the air. So again, you've got two answers here mathematically that make sense, but they both represent time in seconds. Well, let's think here. If you actually physically jump in the air, 0 seconds does not make any sense because if you leave the ground for any amount of time, it can't be 0. Even though 7/8 of a second is a really short amount of time, that would be your answer in this case. So here's an example again of a word problem where you get answers that, again, we need to think in context of what the answer would be. Mathematically, you get two numbers that algebraically make sense, but again, in terms of the context of the problem, the 7/8 makes more sense at 0 because 7/8 is the actual amount of time you can be in the air, albeit very short. So, in short, that's how we use some zero product property with one of our factoring strategies that we've learned. Again, you're going to see zero product property, GCFs, you're going to see all that stuff integrated throughout the next several lessons, so that is something you're going to continue to build on and continue to practice. So, assignment that's going to go with this, you'll see posted on Schoology up as either a worksheet or as its own assignment that you'll need to complete and submit on there. So this is not on IXL, it's going to be its own thing where you'll have to show some work. So, if you have any questions, again, about anything within the notes, need any explanations, shoot me an email, send me a Schoology message, find some time here, we can get together on Zoom and talk through some problems. I'll be happy to help you as you need. Otherwise, make sure you complete the assignment that goes with this. Make sure you take care of the LCM and GCF assignment from earlier in the week. Make sure you take care of both those things and submit by the appropriate deadlines. Otherwise, thanks for watching. We'll see you next time.